In this session, we are discussing differentiation of composite functions. This is the theorem. If y is equal to f of u is differentiable function of u and u is equal to g of x is differentiable function of x such that the function y is equal to f of g of x is differentiable function of x, then dy by dx is equal to dy by du into du by dx. Now, this is the theorem which I am explaining with the help of example. The derivation of this theorem we will take later in separate video. Now, look at the example. Question is differentiate sine of 2x plus 3 with respect to x. Now, to differentiate this, look at the method. I am assuming let y be sine of 2x plus 3 and I am assuming u as 2x plus 3. So this you can write as y is equal to sine u. Now we want dy by dx. So dy by dx can be written as this is dy by du into du by dx. So d by du of sine u into d by dx of u. U is what? 2x plus 3. Now further, this dy by dx can be written as, now derivative of sine u is cos u into, now how to take the derivative of this 2x plus 3? 2 is constant into derivative of x is 1, the derivative of 3 is 0 as it is constant. So what I get here is 2 cos of u. Now from this dy by dx can be written as 2 into cos of. Now we are substituting the value of u, that was 2x plus 3. Now this is what the derivative of cos of sine of 2x plus 3. Now this method is called as chain rule. So this function was composite function and we can differentiate this with the help of this chain rule. Now this chain rule I am explaining for some of the basic formulae. See, you have studied some formula like derivative of sine x, and you know derivative of sine x is cos x. But now if derivative of sine of f of x is asked, f of x is some function of x, it is not just x, it is some function of x, then derivative of this is cos of f of x into f dash of x. I am explaining one more formula with the help of this. I hope you remember what is derivative of log x. The derivative of log x is 1 upon x. So what is derivative of log of f of x then? So derivative of log of f of x is 1 upon f of x into f dash of x. So basically whatever coming in place of x as a function of x, f of x, its differentiation I am writing here. The next one is derivative of a raised to x. The formula what you have studied is a raised to x into log a. By the way, then derivative of a raised to f of x can be written as a raised to f of x into log a. Now I hope you understood how to modify the basic formulae with the help of chain rule. So you can modify all the basic formulae in the same manner. Now we are taking some examples to understand this chain rule in detail. Here is the first question. Differentiate cos of x square plus a square with respect to x. So here I start with let y be cos of x square plus a square. Now I'm differentiating this with respect to x. So you can write dy by dx is equal to, now what is derivative of cos? The derivative of, see, this is derivative of cos of x square plus a square. See, if somebody has any confusion in further derivative, then look at this formula. Now I should write derivative of cos of f of x as. I hope all of you remember what is the derivative of cos function. It is minus sine f of x. But then this has to be multiplied by f dash of x also. That is derivative of f of x. So here in next step what I can write is dy by dx is equal to derivative of cos is minus sine x square plus a square into. Now I'm looking for this f dash of x. F dash of x means derivative of this part. So into derivative of x square plus a square. Further, this can be written as dy by dx is equal to minus sine of x square plus a square into derivative of this x square is 2x and a square is constant, so its derivative is 0. Now what I can write as answer? So this becomes dy by dx is equal to minus 2x into sine of x square plus a square. This is the final answer. Now we are going for the next question. And the next question is differentiate e raised to 3 sine square x minus 2 cos square x with respect to x. So again, I'm starting with let y be e raised to 3 sine square x minus 2 cos square x. Now differentiating this with respect to x. So this is dy by dx is equal to, now I have to write d by dx of e raised to 3 sine square x minus 2 cos square x. Now here, this is d by dx of e raised to f of x we have to apply. And what is derivative of e raised to f of x? It is e raised to f of x into f dash of x. So according to that, it becomes dy by dx is equal to. So first part is e raised to f of x only. So here this is e raised to 3 sine square x minus 2 cos square x into, now derivative of f of x we have to take. So what is our f of x? F of x is this part. Look at this one. It is the power of e. So derivative of 3 sine square x minus 2 cos square x. Now this can be written as e raised to 3 sine square x minus 2 cos square x into. Now look at this one. Here now I have to deal with the derivative of 3 sine square x. So 3 is constant out. This is derivative of sine square x minus 2 is out and derivative of cos square x. Now how to differentiate this? So to differentiate this, I have to go for the derivative of sine square x. I have to go for the derivative of cos square x. And for that purpose, pay attention here. See, I'm referring to the formula now. Derivative of f of x raised to n. The derivative of f of x raised to n is n into f of x raised to n minus 1 into f dash of x. So look at this one. What you can write is dy by dx is equal to e raised to 3 sine square x minus 2 cos square x into, this 3 is as it is. Now derivative of sine square x we want. And according to this formula it becomes 2 into sine x into derivative of f of x. F of x is now sine x. So derivative of sine x minus 2 into. Now we are getting derivative of cos square x. For cos square x it is 2 cos x into derivative of cos x. And next step dy by dx can be written as e raised to 3 sine square x minus 2 cos square x into, this is 6 sine x into derivative of sine x is cos x minus 4 cos x into derivative of cos x is minus sine x. In next step, this can be written as e raised to 3 sine square x minus 2 cos square x into, this is 6 sine x cos x plus 4 sine x cos x. Now what is 3 sin x, what is 6 sin x cos x plus 4 sin x cos x? So value of this bracket becomes 10 sin x cos x. And this first term remains as it is. E raised to 3 sin square x minus 2 cos square x. That remains as it is. Now what in next step I can write is dy by dx is equal to e raised to 3 sin square x minus 2 cos square x into this 10 can be modified as 5 into 2 and for the sin x cos x is same. Now I hope you remember what's the reason for writing this way. In trigonometry, you might have studied some formula for 2 sin x cos x. And what was that formula? The 2 sin x cos x can be written as sin 2x, while I'm keeping phi as it is. So, my dy by dx is e raised to 3 sin square x minus 2 cos square x into 5 sin 2x. This is my final answer. I'm going for the next question here. The question is differentiate log of sec 3x into tan 3x with respect to x. Again, I'm starting with let y be log of sec 3x plus tan 3x. Now, differentiating this with respect to x, you get dy by dx is equal to. Now, question is how to differentiate this. So, here is the basic formula. D by dx of log fx is 1 upon fx into f dash of x. So shall I start with the derivative directly? Now here derivative of log is 1 upon function. Now what is function here? Sec 3x plus tan 3x into you have to differentiate the f of x, that is sec 3x plus tan 3x. Now in next step I have to write the derivative of sec 3x plus tan 3x in numerator. And for that purpose, look at this one. See, derivative of sec fx is sec fx into tan fx into f dash of x. Basically, derivative of sec x is sec x into tan x. So here I get this as sec 3x into tan 3x into derivative of f of x means derivative of 3x plus. Now what is derivative of tan 3x? I hope you remember derivative of tan 3x is sec square 3x into, here also some other function of x comes and that is 3x. So into derivative of 3x. While I'm keeping the denominator same, that is sec 3x plus tan 3x is my denominator. Now in next step, dy by dx becomes, observe this derivative of 3x, you can write as 3, this value. What is derivative of 3x? It is simply 3. Here also, this is derivative of 3x, it is 3. So this 3 sec 3x I have taken common from numerator. So this becomes 3 sec 3x. In bracket, what remains is tan 3x plus. Now sec 3x we have taken common from the square, sec square 3x. So 1 sec 3x remains here. And now denominator is sec 3x plus tan 3x. Now what happens is these are cancelled and I got simply dy by dx is equal to 3 sec 3x. This is my final answer. Now this is the next question. Question is differentiate log of 4 raised to 2x into x square plus 5 upon root of 2x cube minus 4 raised to 3 by 2 with respect to x. So here I start with the solution. Again I am assuming this as y is log of 4 raised to 2x into x square plus 5 upon square root of 2x cube minus 4 the whole raised to 3 by 2. Observe, here I am not starting with differentiation immediately. Rather than that, what I am doing is, first I am applying certain formula of logarithms to simplify this. And the first formula what I am thinking is log of m into n. The log of m into n can be written as log of m plus log of n. So here, according to that, what I can write is, this is log of 4 raised to 2x plus log of x square plus 5 upon square root of 2x cube minus 4 raised to 3 by 2. Now, one more formula of logarithms I am applying in next step, and that is log of m raised to n is n log of m. See, maybe while studying the theory, you might have said there is some base here. Fine, if there is base a here, then you should write the same base on the right hand side. Now, as in the problem base is not mentioned, we are assuming it as e, and it is same throughout. So in next step, what I can write is y is 2x into log of 4 plus 3 by 2 into log of x square plus 5 upon root of 2x cube minus 4. Now, in next step, I am applying another formula of logarithms, and that is log of m by n to some base can be written as log of m to the same base minus log of n to the same base a. In that case, this becomes, so y is equal to, you may write this as 2 log 4 into x plus this is 3 by 2. Now log of, what you have is x square plus 5, here log of x square plus 5 minus log of, see now this square root can be assumed as power half. So it becomes 2x cube minus 4 raised to half. Now just check whether this much is correct or not. All of you understood this or not? Now in next step, what I can write is, this is y is equal to, now this further can be written as y is equal to 2 log 4x plus this 3 by 2 I'm keeping same. So this is 3 by 2. Further, log of x square plus 5 is same minus. Now this power 1 by 2. Again I'm taking ahead, and this is 1 by 2 log of 2x cube minus 4. Now in next step, one can write this as y is equal to 2 log of 4 into x plus 3 by 2 log of x square plus 5 minus 3 by 4 log of 2x cube minus 4. Now this is what I am differentiating. For differentiating this may be treated as u plus v. This may be considered as u, then plus v minus w, and differentiation of each term can be done separately. So I start with differentiating with respect to x. So when I differentiate this with respect to x, left hand side can be written as, now look at the left hand side, it is simply dy by dx. And for right hand side, this 2 log 4, for first term I am looking for now, it's 2 log 4 is out, into derivative of x with respect to x we have to obtain, plus this 3 by 2 is constant into derivative of log of x square plus 5 to be obtained, minus 3 by 4 is constant into derivative of log of 2x cube minus 4 to be written. Now what in next step? In next step, this becomes dy by dx is equal to, sorry, this is not 2 log x, I made some mistake, it must be 2 log 4. Now this is 2 log 4 into, what is derivative of x with respect to x? It is 1 plus 3 by 2. Now derivative of log of x square plus 5 is 1 upon x square plus 5 into d by dx of x square plus 5 minus 3 by 4 is same. Derivative of log of 1 upon 2x cube minus 4 is 1 upon 2x cube minus 4 into d by dx of 2x cube minus 4. Now, in next step, we have to simplify this further, and for that purpose, what I get is, observe the next step carefully now. Left hand side is dy by dx only. By the way, first term, whatever we obtain, we will keep as it is, and it was 2 log 4 plus, this is 3 by 2 into x square plus 5 into, now derivative of x square plus 5, derivative of x square is 2x, derivative of 5 is 0, minus 3 upon 4 into 2x cube minus 4 into derivative of 2x cube. 2 is as it is. Derivative of x cube can be written as 3x square minus derivative of 4 is 0. Further, dy by dx can be written as 2 log 4 plus, this is 6x, 3 into 2x is 6x upon 2 into x square plus 5 minus, this is 3 into 6x square upon 4 into 2x cube minus 4. In next step, you can write this as dy by dx is equal to 2 log 4 plus, you may simplify this and write here 3, so that becomes 3x upon x square plus 5 minus, this is 2 and this is 3, so it becomes 9x square upon 2 into 2x cube minus 4. You may keep this as final answer, or maybe one can write this as log of 4 square, which is 16, plus 3x upon x square plus 5 minus 9x square upon 4x cube minus 8. This is my final answer. I hope you understood this much. In next session, we will go for the next topic. Here we stop. Till then, goodbye.